Okay, so the final part of the polynomials and quadratics chapter is the intersection of lines. It's really just a skill. You're going to use it at various points as the course progresses. So what we've got here is a curve and a line. The equation of the curve is x cubed plus 5x squared plus 4x minus 9. And then you've got the equation of your straight line, which is y equals x. What we're going to do is find the points of the intersection. So as you can see from the picture, got 1 point of intersection, 2 points of intersection. Okay, so what we're going to do is we're going to find the points of intersection. When we did points of intersection before, we really did it with simultaneous equations back in National 5, and at the points where the lines intersect, the x and the y coordinates are exactly the same for both lines. So therefore, at that point there, you can say that this y is equivalent to this y. And because they equal each other, you can then make their equations equal each other. Okay, so I can therefore say that x cubed plus 5x squared plus 4x minus 9 equals x at the point of intersection. So to go on and solve this, just like your quadratic equations, you need to make it equal to 0. So I'm going to bring the x over to join the rest of the terms. So I'm going to take this x over, so it's positive, so I'm subtracting it. So that leaves me with 3x minus 9 here, which leaves me with that. And then I can go on and solve that. And the way you go on and solve that is to factorise and find the roots. So to factorise a polynomial, you use your synthetic division. So I'm going to take the coefficients in front of each of this, and I'm going to come up with values which are going to make no remainders. So you're looking really at factors of 9. So looking at 1, 3, and 9, or minus 1, 3, and 9. So let's start off with 1. It's just trial and error unless you get more guidance from the questions. So drop the 1 down, times by 1 to bring it up, add to bring it down, times by the 1 to bring it up, add to bring it down, times by 1 to bring it up, and then you get 0. So then you would write no remainder, so x minus 1 is a factor. Okay, so because that's a factor, it allows me to then go on and factorise it. So I have x minus 1 is the factor, and that leaves me with this quotient part, which is your final bracket. That's what you're left with after you divide by the x minus 1, and then I'm left for this. And then I can go on and factorise this further. That gives me x plus 3, x plus 3. And of course, each of these are equal to 0. So therefore, I have x equals 1, and both of these brackets will provide me with the solution of x equals minus 3. Go back to our picture, if you just look, x equals 1, x equals minus 3. Looks about right, because I'm going 1 along, 3 back. Now, to find the points of intersection, you obviously need 2 points of intersection. You need 2 parts to your points of intersection, so you need your coordinates. So I've got my x parts of the coordinates, I need the y parts of the coordinates. You get that from your equations for y. So you can substitute in the 1 and the minus 3 into either of these. Now, looking at them, which one do I obviously want to use? I obviously want to use the easier one. So I'm going to substitute the 1 and the minus 3 into this equation. So I'm going to use y equals x, and then I'm going to replace x with 1 and minus 3, which is hopefully obviously going to give you the point of replacing the x with 1, y equals 1, replacing the x with minus 3 gives you minus 3. So my points of intersection are where x is 1, y is 1, and when x is minus 3, y is also, in this case, minus 3. Okay? If you substituted 1 and minus 3 into here, you would get exactly the same answer. So just we'll do it quickly with the 1. So you got 1 cubed, add 5, add 4. So 1, add 5, add 4 is 10, take away 9, also gives you 1. Okay. Okay, so we've got example number 2. We're going to do exactly the same thing. This time from the picture, we can hopefully see that we've got 1, 2, 3 points of intersection. If we zoom in a wee bit there, yeah, grand. So, this time the question asks us to show that the graphs intersect at -1, -20. So, okay, so our two graphs are x cubed minus 12x squared plus 27x plus 20 and minus 2x minus 22. Okay, so we're going to show that the graphs intersect at -1, -20. Now there's two ways to do that. So I'll show you both ways. You can decide whichever way works for you. The first way is to show that the graphs intersect at -1, -20 is to show that they both have that as a coordinate. So what you could do is substitute -1 into here and see if you get the answer of -20. So let's go for that. So I'll do -1 cubed minus 12 minus 1 squared, add 27 minus 1s, add 20. Now I'm going to ask you to not use a calculator just because it's good practice. -1 cubed is -1, -1 squared is +1, so that's -12. Add 27 times -1, which is -27, add 20, which if you tidy all that up, ends up being -13, -40, add 20 is -20. So the first part's worked nicely. Second part, substitute -1 into the second equation, and you get -2 times -1, -22. So therefore, -2 times -1 is 2, -22, which also gives you the answer of -20. So therefore, both points, or both lines, have the coordinate -1, -20, okay, where they both pass through those points. That's one way of doing it. The second way to do it, and that's just generally the way I would do it, is to do it similar to the first example, okay? So that you set them up as a simultaneous equation. So I've got x cubed minus 12x squared plus 27x plus 20 equals -2x minus 22. We're going to solve it. So therefore I have to make it equal to 0. So x cubed minus 12x squared. Take the 2x over to join it. Take the 22 over to join it. So you get plus 42 equals 0. Now, if the points intersect, when I do my synthetic division, I should not get any remainder. So therefore that's what I need to demonstrate. Okay, so x equals -1 here in the coordinate. So because x equals -1, that's what goes outside. Drop the 1 down, times to bring it up, add to bring it down, times to bring it up, add to bring it down, times to bring it up. So then you'd write no remainder. So x equals -1 is a point of intersection. And then just check. So y equals, and then sub x equals -1 into one of the other points. So I'm going to choose the easier one. And I get -20. So therefore you kind of demonstrated it. Alright, now the reason for doing it the second way, doing your synthetic division, is it helps more often than not to solve part B. So if you look at part B, it says find the coordinates of the other points of intersection. In order for us to do that, we have to factorize this, which we've done by doing it this way. Doing it the other way, you're going to then have to do the synthetic division again, so therefore you might as well just do this way to save yourself having to do both ways. So if x equals -1 as a point of intersection, the factor is x plus 1 is your bracket. So therefore get the other bits from here. So you get x squared minus 13x plus 42 Okay, and then I'm going to think about what times is to give me 42. But then adds to give me minus 13, and that is 6 and 7. So it's minus 6, minus 7. Alright, and they both equal 0. Alright, so therefore my roots are x equals minus 1, x equals 6, x equals 7. Alright, now I know the solution for y for this one, because it told me in the question, it told me that's minus 20. So now all I need to do is find the solutions for y when x equals 6 and x equals 7. So therefore I'll go to the easier equation, minus 2x minus 22, and I'm going to sub in what x equals 6. So minus 2 times 6 minus 22. So I get minus 12 minus 22 is minus 34. And then do the same with the 7. So I've got minus 2 times 7 minus 22, which is minus 14 minus 22, which is minus 36. So the points of intersection excuse the dog, are minus 1 minus 20, 6 minus 34, and 7 minus 36. Okay, so example number 3, similar sort of question eventually, but this is more how they'll ask it in the exam. They'll give you a piece of information and then they'll link it to the next stage. So your solution for part A, show that x minus 3 is a factor of that. Well, that's just doing your synthetic division. So take the coefficients in front of each of the things. So you get 1, 1, minus 8, minus 12, and if x minus 3 is a factor, x equals 3 is the root, and the 3 is what goes outside. So drop the 1 down, times to bring it up, add to drop it down, times to bring it up, add to drop it down, times to bring it up, and then you get no remainder. So x minus 3 is a factor. So that little sentence there can change depending on what you're asked to show. You just have to make sure that if you're asked to show that x minus 3 is a factor, that is the final part of your sentence. Okay? Right, going on to part B. Now, we got to find the points of intersection of these two curves. So you're going to do it in the same way as what you did before. You're going to make them equal each other. So I've got x cubed minus 4x equals 12 plus 4x minus x squared. Okay, now to go on and solve that, I'm going to move everything and I'm going to move it to the side with a higher power so that the higher power is positive. So I'm going to take these 3 over to join this. So then I have x cubed minus x squared becomes plus x squared. Plus 4x becomes minus 4x, which gives me minus 8x. And then minus 12 equals 0. Okay, now if you look at that expression we've got there, that is exactly the same as what we had in part A. Okay, so therefore, because that's the same as what I had in part A, I can then continue to write this. Now there's no need to do the synthetic division again, but I know that x minus 3 is a factor of this, so therefore I can write that down. And then my second bracket I get from the synthetic division. So I've got my x squared plus 4x plus 4 equals 0. And then I can go on and factorize that expression to x plus 2, x plus 2. Okay. My roots therefore are x equals 3, and both of these brackets will give me a root of x equals minus 2. And therefore, to get the point of intersection, I need the y values to go along with the x values. So therefore, I'm going to substitute these x values into one of the formulas for y. At this point, it's whichever one you like the look of. Obviously, the previous examples have been easier to just judge. I'm going to go with this one for no particular reason. So I'm going to replace each of the x's with in the formula for y. So I'm going to have 3 cubed, take away 4 lots of 3, right? 3 cubed is 27, 3 times 3 times 3, and then take away 12, which leaves me with the answer of 15. Okay, so that point of intersection is 3, 15. And going over to this one, replace the y, the x's and the y with -2. So get -2 cubed minus 4 lots of -2. Please remember the brackets for a negative number. Right, -2 cubed is -8. -4 times -2 is +8. So therefore that is 0. So therefore the final point of intersection is -2, 0. Okay, final example. We're going to show that the curves y equals x cubed plus 7x squared plus 15x plus 20 and y equals -2x intersect only when x equals -4. So what we really want to do here is we want to demonstrate that there is only one root when the lines intersect. So we're going to do it the same way as what you normally do. You're going to make them equal each other. So these y's equal each other. So therefore the expressions equal each other. So therefore you can have x cubed plus 7x squared plus 15x plus 20 equals -2x. Okay, so what we need to do then, same thing as we've done before, is we need to make it equal to 0. So therefore we're going to take the -2x over to join the rest of the terms. So I've got x cubed plus 7x squared. My -2x becomes +2x. So I'm going to add it on to the 15x. So I get 17x plus 20 equals 0. And then I want to show that it intersects only when x equals -4. So therefore, I know that that is a root. So therefore, that is the value I'm going to use when I do my synthetic division. So I've got 1, 7, 17, 20. And I'm going to put my -4 outside. So drop the 1 down, multiply to bring it up with the -4, add to bring it down, multiply to bring it up, add to bring it down, multiply to bring it up. So you've got no remainders. Therefore, you've just demonstrated that x equals -4 is a root. Okay, so you would write no remainder. So lines intersect at x equals -4. Okay, now we've dealt with the first part. The part we haven't dealt with is the word only. So therefore there should be no further roots. So let's go back to this and let's complete the factorizing. So I could take this expression, start factorizing it, and I know that when x equals -4, it was a root, so therefore x plus 4 is a factor. I'm going to get my rest of my terms from here. So I've got my x squared plus 3x plus 5, and that equals 0. Now, if I was to be able to go on and factorize this further, that would give me my further solutions. However, I don't think I should be able to factorize that further because it says it only intersects once. So therefore I'm going to use a discriminant to test whether there are any further roots. So I'm going to do b squared minus 4ac, and that should be negative if I can't factorize it further. So my b is 3, take away 4 times 1 times 5. So that's 9, take away 20. So that is -11. Therefore, my b squared minus 4ac is less than 0. Okay, therefore there are no real solutions, okay, for this part. As such, x equals -4 is the only point of intersection. Okay, it doesn't ask me to do any more than that. Now the reason for me showing you this example is you could very easily rephrase this question and say, find all the points of intersection of these two lines. In which case you would do all this step, you get to here, and you'd have to demonstrate that you know that there's no further points of intersection by doing the discriminant. Okay? That'll do us. Thank you very much.